Hello everyone, welcome to Math World. Please hit the subscribe button and kindly join as member to get the early access to the new videos and also the access to the members only videos. Okay, so let's start. So this video is to discuss the partial fractions. Okay, basically for partial fractions, right, we are looking for the rational function, or I would say proper rational function. Okay, so you can apply this directly to proper rational function, which means the degree of the x in the polynomial is less than, okay, the degree of the x in the divisor. Then that is called proper rational function. Otherwise, it is called as improper rational function. Okay, so basically, if you are given proper rational function, we can just check this table to identify the partial fractions. Okay, so now, just for information, let's say here, we will always refer to the factors in dx when you are given this rational function. Okay, dx is the divisor, and also I will say that it is called the denominator. All right, this is a divisor and it is the denominator in your rational function. And let's say this is the example for the factors of dx, and this will be the corresponding partial fractions. So I use PF to represent partial fractions. Now we have three cases. The first case is you are given linear factors. So let's say, for example, your denominator now consists of ax plus b and cx plus d. So any two general linear factors. So your px, right? So it will be a over ax plus b plus b over cx plus d. Okay, so here we will just check the factors in the dx. That's why I will give you these two as the factors in the dx. Okay, example of dx. All right, so now here, the second case is you are given repeated factor in the divisor. Okay, just an example. Probably ax plus b multiplied with square of cx plus d. So the square is outside the bracket. That is called as repeated factors. So your partial fractions, it will be a over ax plus b, because whenever it is linear factor, ax plus b is a linear, the numerator must be a constant. Okay, and now this is also linear. So I will write b over cx plus d, but then with degree 1, even though you are given degree 2. So you must start with degree 1 and followed by c over cx plus d squared. Okay, so the c in the denominator and the c in the numerator are different c, because one is capital letter C and the denominator will be the lowercase letter c. Okay, so now the third case is going to be quadratic factors, which means you are given probably ax squared plus bx plus c. Okay, multiplied with ax plus cx plus d. So which means now here this quadratic cannot be factorized. Then here will be dx plus e, for example. Then in this case, our partial fractions becomes, okay, over ax squared plus bx plus c. This one cannot factorize. Okay, can't be factorized. So if you cannot factorize the quadratic, that means that is the third case. So since the denominator now is a quadratic function, therefore it is a linear function. We get the idea from the factor theorem in the previous video. And then plus dx plus e. Okay, so when dx plus e, this is linear function, therefore the remainder is constant. Alright, so these are the three cases for the partial fractions as long as you are given proper rational function. Okay, so if you are given improper rational function, okay, let's say here I give you the improper case. So when it is improper rational function, that means, okay, your first step is polynomial division. So improper means that the degree of the x in the px is greater than or equals to the degree of the x in the dx. Alright, that is called improper. And then second step is partial fractions. So your partial fractions must apply to proper rational function. Okay, so that's the two cases. These are the two cases of partial fractions. Okay, so now let's solve the example. Number 1, express the following rational functions in partial fractions. So this is the first question. So now first of all you check. If I do expansion for this, it is x squared, which means now here I'm getting a improper rational function. Okay, so what I need to do is, firstly, I will just do expansion because I need to perform the long division or polynomial division before the partial fractions. So when you do expansion, this is x squared, 2x, 1x, total 3x. And then 1 times 2 is plus 2. And now I have to perform long division or polynomial division. 5x squared. So after 5x squared supposedly will be x and then constant. So I add on 0x and 0. And the divisor x squared plus 3x plus 2. So now to get 5x squared from x squared, I need to times with 5. So it will be 5x squared, 5 times 3x plus 15x, 5 times 2 plus 10. Then you minus. First term you get 0. Second term 0 minus 15, that is minus 15x. Last term 0 minus 10, that is minus 10. So with the polynomial division, I will change this into 5. Okay, quotient plus remainder plus minus 15x minus 10 over the divisor. This divisor we use back the original factors. So x plus 1 times x plus 2. But then if we check, now the numerator both are negative. That means we can factorize a minus. So once you factorize this minus combined with the plus, that is minus. So I will rewrite this as 5 minus 15x plus 10 over x plus 1 bracket x plus 2. Okay, and now my partial fractions will be found based on this. Okay, this one I have to find partial fractions. Later I will just combine back to get the final answer. So I will let 15x plus 10 over x plus 1 times x plus 2 equals to, okay, now here rewrites the denominators. So when you check here, you are given two linear factors, right? That means the numerator should be constants a and b. And now to get the two values, the a and b, we need to compare to the left side to get the same denominator, which means now here I will be getting 15x plus 10. Here is x plus 1, then x plus 2. Now when you compare, I will firstly rewrite this, and then now I need to times with x plus 2 because I have x plus 1 both sides. So I times x plus 2 at the bottom here and on top so that it will be cancelled off to get 1. Use the same method for the next term. So now I have x plus 2, which means I need to multiply with x plus 1. Okay, so when you compare both sides, that means now you are getting same denominators. So what I need to do is I will just cancel all the denominators and consider all the numerators. So I will be getting 15x plus 10 equals to a times x plus 2 plus b times x plus 1. And now, to get the a and b, you have two methods. The first is you can just replace the x values to get the, and then do the comparison. That is called substitution method. Otherwise, you can use elimination method, means you let the factor be 0. So that is what I'm going to use, right? I will let x plus 2 be 0, then my x is going to be minus 2. Now I will substitute x equals to minus 2 into this whole equation to get the a and b. So which means I will get 15 times minus 2 plus 10 equals to, now for the first term on the right side, since I let it be 0 just now, that means this will be 0. So 0 times a, it will be 0. So I will just consider the b directly. So which means b bracket minus 2 plus 1. Okay, so minus 30 plus 10, that is minus 20. This is going to be minus b, hence my b is 20. Okay, so now next step is let the second factor be 0. So I let x plus 1 be 0. Therefore, your x is going to be minus 1. Same concept, 15 times minus 1 plus 10, substitute into this equation. It will be a bracket minus 1 plus 2. The b brackets x plus 1, the x plus 1 will be 0, so whole term will be 0. That means now here I will be getting minus 5 equals to a. Okay, I have found a and b, so I will substitute back these two values into the partial fractions, which means now I will get 15x plus 10 over x plus 1 times x plus 2 equals to minus 5 over x plus 1 plus 20 over x plus 2. Okay, after this, not to forget that that is not our final answer. Our final answer will be this whole term. Alright, so I will copy the question first. 5x squared over x plus 1 times x plus 2 is 5 minus these two terms. So now to get the simpler form, just times this minus into the terms inside the brackets. So it will be 5 plus 5 over x plus 1 and minus 20 over x plus 2. So that's all for my partial fractions of this question. Okay, next question. You are given this rational function 4x minus 11 over x plus 3 and x minus 1 squared. So first of all, I will rewrite the question. Now, before we start, you have to check whether this is proper or improper rational function. So the degree of the numerator is 1 for the x, and the degree of denominator, obviously, when you do expansion, this is going to be x cubed, right? So this is the proper rational function. Therefore, I will just continue with the partial fraction. So here is going to be x plus 3 plus. Now the second one is actually the repeated factor because the square is outside the bracket. So I will start with degree 1 and followed by degree 2. So since all these are linear factors, because x with degree 1, the numerators will be constants. And then now use back the same concept. Always compare with the left side to get the same denominators. So I need to times with square of x minus 1. Okay, and for the second term, I have x minus 1. So now when you compare, I have x minus 1 degree 1. That means here I need another degree 1 and I need to times with x plus 3. So which means I will have x plus 3 and x minus 1 plus c over x minus 1 squared. So times with, now the x minus 1 squared is given, so you need to times with x plus 3 now. Okay, so after this, since all the denominators are the same, I will just rewrite my numerators. So the dots here means times. So this is what I'm getting. And again, to find the unknowns, all the constants a, b, c, I will just use the elimination method just now. I let x minus 1 be 0. Therefore, my x equals to 1. Okay, because my first factor is x minus 1. So now I will replace the x by 1. So 4 times 1 minus 11. As long as you see x minus 1, okay, which means here, as long as you see this, it will be 0. That means first two terms will be 0. Then I can direct find the c. So which means now here I will be getting c bracket 1 plus 3. Okay, then you will be getting minus 7 is 4c. Therefore, your c is minus 7 over 4. Now, next step is let next factor be 0. That means x plus 3 be 0. Therefore, your x equals to be negative 3. Now, you replace 4 times negative 3 minus 11 equals to a times. Okay, now check. As long as you see this, right, x plus 3, I will let it be 0. That means this is 0. This is 0. So I will be getting the a. And replace the x by minus 3. So minus 3 minus 1 squared. That means now here I'll get minus 12. Okay, minus 4 times minus 3 is minus 12. Minus 12 minus 11, you will be getting minus 23. Then the right side, minus 3 minus 1 is minus 4. You square that, it's 16. Hence, your a is negative 23 over 16. Okay, now when you check here, when you check this equation, basically just now I let x plus 3 be 0. And in the first step, I let x minus 1 be 0, which means we don't have other factors. So, but then we have one more unknown, b. So we need to find out one more equation in order to solve that unknown. So what to do now here is you can just let x be any other numbers. I let it be 0. So when let x be 0, I will be getting 4 bracket 0 minus 11. Just replace now. It will be a bracket 0 minus 1. So I will write minus 1 squared plus b 0 plus 3. So b 3 bracket 0 minus 1. So it's minus 1 plus c bracket 0 plus 3. That is 3. Okay, I'm getting this equation now. So since a and c already found, just replace. So I will get minus 11 equals to minus 23 over 16. Negative 1 square of negative 1 is positive 1. So no need to write. Or probably you just write 1. 3 times minus 1 is minus 3. But then there is a plus outside. Therefore, minus 3b. Then plus 3c. So plus 3c. Okay, so then from here, I can just keep my minus b on one side. Okay, all these terms move to the left side and combine with the minus 11. So when you simplify it, it becomes minus 69 over 16. Then your b is going to be minus 69 over 16 times minus 1 over 3. Then that is going to be 23 over 16. So after you found these three unknowns, okay, what to do is substitute back into the first step. Then I will be getting 4x minus 11 over x plus 3, x minus 1 squared. That is going to be a over x plus 3. So my a is negative 23 over 16 divided by x plus 3 plus b over x minus 1. So b is positive 23 over 16 over x minus 1 plus c over x minus 1 squared. So the c is negative 7 over 4. So, and again, for this case, since you have the fractions in all the numerators, so we will factorize the whole fraction. Then I will just write 1 over x plus 3. And same goes to the second term. It will be 23 over 16 times 1 over x minus 1. And the third term, okay, this minus and plus combined together becomes minus. So minus 7 over 4 times 1 over square of x minus 1. So this will be my partial fractions. Okay, done for this question. Now third case, you need to solve 8 over x minus 4 times x squared plus 1. So when you check here, the numerator does not have any x. That means this is the proper rational function. Then we can just go to the partial fractions directly. And now we check here. This is a quadratic function, but then this quadratic cannot be factorized. So I will just write plus x squared plus 1. Okay, so since the first one is linear factor, numerator should be a constant. And the second one is a quadratic that cannot be factorized, then numerator must be a linear function, bx plus c. Okay, so use back the same concept, compare with the left side to get the same denominator. So you will get a over x minus 4 times x squared plus 1, because I have x minus 4. So times by x squared plus 1, and plus bx plus c over x squared plus 1. So now the quadratic factor is given, therefore you times with x minus 4. So now rewrite the numerators. Now be careful with this. Bx plus c times with x minus 4. So the student used to just write directly bx plus c times x minus 4 without the brackets for bx plus c. So it's very easy to make mistake later on. So please put the bracket to the bx plus c and another bracket for the x minus 4. Okay, so now again here, to calculate the three unknowns, I will let the factor be 0. So now I let this x minus 4 be 0. Then you will get x equals to 4, which means now left side does not depend on x, just rewrite the 8. And then here I get 4 squared, a times 4 squared plus 1. And I let x minus 4 be 0, that means the second term will be 0. Then here 8 equals to 4 squared plus 1 is 17. So 17a. Hence your a is going to be 8 over 17. Okay, next, supposed to be this quadratic be 0, but x squared plus 1 equals to 0, your x squared is minus 1. So we know that x squared cannot be minus 1 because in partial fractions, your x must be real numbers. Okay, so real numbers, x squared must be minimum 0. So in that case, we cannot let x squared plus 1 be 0. What to do is, you just let x be any numbers. So I will start with x equals to 0, because I do not want to solve the simultaneous equation. If you substitute x by other values, then you have to solve simultaneous equations. Okay, so now when x equals to x equals to 0, left side is still 8. Right side I will get a bracket 0 plus 1, just 1, plus 0 times b. I will just ignore the b and just c. 0 minus 4 is minus 4. Okay, and now here I will replace the a value. So I will get 8 minus a equals to minus 4c. Alright, then from here, basically, my c, okay, or I calculate first. So my 4c, or my negative 4c is equals to 128 over 17, 128 over 17. Then now my c equals to minus 32 over 17. Okay, you just divide by minus 4. I found the c. And now to get the b, okay, a and c are found. So to get the b, just replace the b by just replace the x by any other value. Let's say x equals to 1. So you can let it be any other values, no problem. So 8, then a bracket 1 squared plus 1 is 2, plus 1 times b, the c replace minus 32 over 17, and then x is 1. 1 minus 4 is going to be minus 3. And now here you just need to do expansion. Just times this minus 3 to the brackets. So here 8 equals to 2a. Okay, my a is found, 8 over 17. I will just replace. Okay, then minus 3b. So I'm supposed to replace the a in the previous step. So I will replace here first. Okay, so that here I will just direct calculate how much is that. This is going to be 16 over 17. And then minus 3b. So the negative 3 times negative 32 over 17, that is going to be plus 96 over 17. Okay, so now this minus 3b will be moved to left side, and then the 8 will be moved to right side. So I will get 3b equals to negative 24 over 17. Therefore, my b divide the right side by positive 3. That is going to be minus 8 over 17. Okay, so found the a, b, and c. Last step is just to replace all these values in the beginning step. So I will write 8 over x minus 4, x squared plus 1. That is a over x minus 4. So my a is 8 over 17. Plus bx plus c. So my b is minus 8 over 17. This is my b, x plus c. But plus and minus the c. Okay, and plus and the minus of 32 over 17, that is minus 32 over 17. This is a bx plus c over x squared plus 1. And again, when you get the fraction in the numerator, just factorize it. Okay, so for the second term, look at here. Basically, minus 8 over 17 and minus 32 over 17, the common term is minus 8 over 17. Right, so I will just factorize that and combine with the plus at outside here. That is minus 8 over 17. Then 1x plus 4. Because when you factorize the minus 8 over 17, it's like you divide the negative 32 over 17 by negative 8 over 17. Therefore, you are getting plus 4 over x squared plus 1. Okay, so this will be the partial fractions of this question. Alright, so with this, we have completed the video. Thanks for watching. Please subscribe to the channel and share this channel with your friends if you enjoy watching my video. And kindly join as member so that you can access to the members only videos. Okay, thank you for watching and stay tuned for more upcoming videos. Thank you everyone. Bye.